Answers from 7-6. Pause it when you need it. There's 14. 26. 40. The constraints from the word problem. Using your calculator, hopefully, to graph each of your functions, and then plug and chug into your cost. Wait, guys, could it take time to plug in each and every one of these to your calculator? Is there a simpler way, if you want to plug into something repeatedly, is there a simpler way of using your calculator? Stat plot, I suppose you kind of could, like put it in and then go to a table and then figure it out from that way. But guys, doesn't your calculator know function notation? Why am I talking about saving time on long problems if we're thinking about what's coming tomorrow? Yeah. So if I'm saying you're allowed to use your calculator, you can graph the constraints and get the sketch that way, use the calculator to find your vertices. I'm also saying you can use your calculator to plug in. Not that this will take you tons of time, but I just want to remind you really fast that you could theoretically put in your objective function. Where do we put in equations, guys? Calculus. Where do we put in equations? We could put in our objective function. I can get rid of this now because calculus already did their job. I could put in my objective function of 1000x plus 1500y. Oh, what's the bummer though? Okay, so can I use my calculator to help me out with this one? No. Reason being, I have two variables. So it's an E for effort, but can we still use our calculator to solve? Yes, we can. And to graph? Yes, we can. And to find intersections? Yes, we can. That was our last one from 7-6. This is your test review, but real quick before we move on, is there anything you guys want to talk through at all from 4-6? Sorry, 7-6? Sean?
Number 37, I couldn't quite figure out my lines. Well, yeah,
Okay.
constraints. Definitely for all one.
What section am I in right now? Systems of equations? I got rid of my table of contents there. Oh no, not here. There, okay. Take 2. Kiddos, while I get up Sean's question, if you don't have your book, go get a book. If you need to borrow a book, go borrow a book. I don't have too many. We need to be reviewing today. I'm going to go ahead and get the test review up so you guys can check it out.
Ready?
We'll talk about specifics once everyone is back. Number 31.
Okay, number 2.
Let me go ahead and get the test review up. I'm going to set up so we can look at number 37. So you guys can go ahead and write down the test review so you have it. It's not super long, but the problems take time. Kind of like the test tomorrow, but we'll talk about it once everyone gets back. So
You got it.
We got perfect. We got perfect.
Then you can put them. Alright, I think we just got everybody back. We're going through our test review as soon as we go over number 37 from 7-6? If you guys didn't get it written down, you can borrow from someone right next to you. I bet they did. But let's go ahead and quickly, I have my calculator so we can look and see how to use it just in case it helps. And let's check out, there we go. The problem from, oh no, there it is. Now, before we go over this, some of you are like, why are we wasting time if we have a test tomorrow? Well, there are going to be two different problems from section 7-6. One is going to be a non-word problem, just solving given a z and given maybe even a graph. Find the vertices testing the table. That's a multiple choicey one. And then there's going to be one long answery word problemy one. Hey, what's number 37? A long answer word problemy one. So let's go ahead and just kind of work through it quickly together and make sure that we get the idea. And then we're kind of done with 7-6, and let's just go to the review. Sound good? I said something while a few of you were out. I was like, hey, the test review, if you look at it, looks kind of short and sweet. How come? Because the problem takes time. So it's going to be like your test tomorrow. Short and sweet. Meaning, I think there's like 15 problems, maybe even 14. Oh, that's not very many. But it's going to take time, right? You're going to have to work quickly and efficiently. I am going to grade partial credit, but guys, you need to make sure, or at least try your best not to make little mistakes in the math, alright? Because I have to make them worth quite a few points each if there's only 13 or 14. But I am going to definitely be grading partial credit even on multiple choice. Let's go check out number 37. I'm going to go ahead and try to put this little guy down below so we can see it. And pull him down. Alright. Kiddos, what are we trying to maximize or minimize? What's our objective? Merchant plans to sell 2 models of MP3 players at prices up. Got it and got it. Whew, those are expensive MP3 players. Maybe this is an old problem. The 225 model yields a profit of. The 250 model yields a profit of only 30 and 31. Struggling. The merchant estimates that the total monthly demand will not exceed 275. The merchant does not want to invest more than 63,000 in inventory. What is the optimal inventory level for each model? What is the optimal profit? Anybody tell what's our objective?
225 x plus 250y is less or equal to 60.
Okay, those are some of our constraints, right?
Mm-hmm.
Okay. So we have constraints of 225 or same model 1 is x, model 2 is what? What does that stand for? How much money is coming in, right? So are we going to set that one like equal to or like less than? I'm not sure if it necessarily tell us the 225 and the 250, do they? Oh, wait. The merchant does not want to invest more than 63,000 in inventory for these products. What does that mean, inventory? It's how much the stuff is that you have like ready to sell. It's the worth of the products that you have. The 225x and the 250y actually needs to stay less than or equal to 63,000. Does that make sense?
Yeah.
He doesn't want any more than that. So he doesn't want any more products. He doesn't want any more than $63,000 worth of product for these MP3 players in his store. Okay. What else?
For profit.
Yeah, but I don't think it tells us like a limitation on the profit, does it? I see this whole will not exceed. What's that thing about? Will not exceed.
Like x plus 5 will be less than or equal to 6.
Yeah. However many people will buy for that month, however many X's and however many Y's, he doesn't see it exceeding 275 units. Okay, good. Is there anything else that's like a limitation?
Yes, it has to be positive.
Oh, so x has to be greater than and y has to be greater than. I think that's it, right? Okay. So we have all of our limits. Now some of you guys are talking about profit, and I totally agree that's super important for our problem. The question, what is profit? A constraint or an objective? Oh yeah. So hold on. How does or what kind of profit is he making? 30 per, is that x? X. 31 y equals E for profit. Sound good? Okay. Now, we're allowed to use our graphing calculator. Why am I going to go ahead and pull him up then and start graphing things like y? I'm going to say equals, even though I'm going to make it less than in just a second. Negative 225 over 250x. What am I doing? Solving for y, aren't I? And I'm cheating and saying, why waste time on simplifying if I can just write it in my calculator? It does it for me. Doesn't that sound good?
Plus 252 and the 63,000 divided by.
Does that make sense? We're going to subtract that guy and we're going to divide that guy. Got him. And we need to go ahead and be less than that, right? So you can turn on your whole little less than thing, or you can just go over here and say, oh my goodness, taking forever. We're going to shade down, yeah? Some of you could visualize that, of course, but we'll go ahead and just make it all shaded and nice and pretty. That's up and that's down. Okay, what am I going to do for my next equation? Is he down also on here? Yeah, okay. Let's get him down.
Why would you put in negative?
Good, negative x plus. So you guys see how I'm using my calculator to save me a lot of time to get these graphs? Let's go ahead and get our graph. Uh-oh, what do you think our window is going to be? 63,000 divided by 250. Can anybody divide 63,000 by 250? How high do I have to go for that intercept? I'm thinking like 1,000, but I might be a little bit off. 63,000. Oh, it's 252. Yeah. Okay. So let's go ahead and let's go like 100. Maybe something about 100. And let's go ahead and go up to like 500. When Karina divided 63,000 by 250, has an intercept of 252. So let's see what this looks like. That's my 63,000 divided by 250 right there. What's going on? You guys see there are actually two lines right there?
Are they parallel?
That's a little bit of a struggle.
They can be parallel.
They're going down to the axis. I don't think I did it far enough. So let's go ahead and change our window. I think the 500 was a little bit extreme. Let's keep going to maybe like 500. Let's see if that's a little bit better. Let's have this just go down to, or go up to like 350. This should be enough. Let's see if that helps. Okay, well, technically we have 275 and we have 257, so they just go to 300. 500 was a little extreme, so maybe let's cut that down to like 400. And as Sean was saying, we're trying to figure out, wait, what's going on? You see how one's there, and I think they switch places. Now, guys, if you don't like this, couldn't you take the shading off and say, you know what, I'll do it myself? Maybe the shading is just complicating things. Maybe we should just go ahead and get rid of that shading. Good idea. He's kind of complicating matters a bit. We can shade ourselves. Alright, which one's which? We have the Y1, then the Y2. The 275 is the one that starts up top. That's this one right here. The 252 is the 63,000 one, which is right there. I think there's an intersection. What do you guys think?
Mm-hmm.
Okay, so we need the second trace. We can find our intersection, which would be 5. Second curve, somewhere there. Where is he? 230, 45. So what I see down here when I try to get my graph, I can say, okay, I have this thing. I have one guy who's going down like this. I have another guy who's kind of going down like, let's see if I can kind of get him. That. I'm exaggerating. I'm exaggerating in my picture just so you can see it, okay? This is our red one. This is our blue one. We just found that intersection to be, what was it again? I remember, I'm exaggerating the picture. This one is the blue intercept, which is going to end up being our, you said 252, right? 252. This one is going to be our red x-intercept. Oh, how do you figure that out, guys? Oh, we can find zeros, right? We can find zeros. So let's go ahead and we need to find our 0. Of course, we could solve with math, but we're trying to see if we can. Oh, that's not going to work so good, is it? Let's go ahead and zoom in. You can find the one that comes first. Which one that comes first? That guy. We need this guy right here. So second trace, let's find the 0. Other one. There we go. 275.0. Maybe we should be able to figure that out just by plugging in, huh? Sometimes the math is faster than the calculator. Okay, guys, at this point, Sean, how's it looking?
I did see the mistake last time.
Easy to do, especially on these guys. We would just have to go ahead and plug in each of our points, right, kiddos? We have our 0, 252. We have our 230, 45. And my guess is the 230, 45 is going to maximize. Anybody have the numbers to fill in real fast just so we can see it? What's the profit for the first one? Oh, you guys can't see it, sorry. 30 times x plus 31 times y? Seems like it, right? We want the optimal profit, and optimal will be maximum, yeah? It's not by much, but technically, which one gets us more? Sound good? So, the optimal inventory is that you want 230 of the first type of MP3, 45 the second type of MP3, and then your optimal profit, the highest you're going to make it, is 8,295, while keeping the restrictions that the dude put in place. Are you tracking, kiddos? Okay. So, tomorrow in the test, there'll be one word probleming, long answer type problem from 7-6, and one multiple choice. Okay? Multiple choice will be like the earlier problems, kind of like some of these ones that had like this sort of thing, where you have certain vertices, you can find them from the graph, you plug and chug to find a max and or min by plugging into the objective. Okay? Let's go back to our review. Some of you guys were writing it down, and as we do that tomorrow, what's going to be on that test? Solving. Maybe substitution, maybe elimination. You guys get to choose. If I say solve the system by any method, solve it with anything but matrices.
Whoa.
Now, could you check technically with matrices in your calculator? Wait, what do you mean by check with matrices? You can do that? What's going on? I want to make sure that we don't have unfair advantages of those of you that remember matrices. Where's like some random yucky system that you wouldn't want to solve? Hey, this one, right? I randomly picked one. Those numbers are gross. Can we not do that? This one. How do you do that in your calculator if you want to check with matrices? Why am I saying check? Because I'm going to look for work. And if there's no work, you don't get all the credit. You get half and maybe even less. Otherwise, you can go to second x inverse. You can edit a matrix. This is technically from next chapter. You can technically make a 3 by 4 And you can plug in each of the coefficients of 2 and 1 and -3 and 4. You can plug in 4 and 0 and 2 and 10. You can plug in -2 and 3 and -13 and -8. Now, you get your little matrix in there. Does anybody remember what to do next to make it solve it for you? Go back to matrix. Go over to math. RREF, row reduced echelon form. RREF. Oops, I went too far. Row reduced, letter B. These are winner, winner, chicken dinner. We want to row reduced echelon form the matrix that we just made, which is A. Now, how much time did that just take? And what does our calculator end up telling us on this one? Oh no, 0 equals 0. Is this one of those let Z equal A ones? Aww. So number 1, can your calculator solve every type of problem from this chapter? No. Could it though, for one of these ones that maybe was a little bit nicer? Could it solve this guy for you? Yeah, but if you had to show work, how much time will it take to put into your matrix and check? No checking until you get to the end. If you have time, you can go back and check with your matrix math and try to check, or with your matrices in your calculator. But don't waste all this time checking in your calculator when you should be solving and moving on to the next problem. Sound good? So one more time, can you use your calculator to check? I just showed it to you. I showed you the cheater trick that'll work on every system unless Z equals A. If you want to talk to me about how to use your calculator you don't know, or talk to a friend, feel free to. That's a good checking system, but I just said if I say solve, I want to see work. But you get to choose substitution or elimination, and that is totally cool. Besides that, kiddos, come with your calculator, come with your notes, your homework spirals. Notes will be turned into the front, homework spirals will be turned into Eileen to the back, and we'll go from there. Sound good? Any other questions about logistics? Alright, so we're going to test review. Have your calculator out. You're allowed to be using it. You can even figure out if you can check with matrices. If you get stuck, let me know. I'll stop the recording now.
They don't look